So picture this. You're producing a massive live event, right? Think a major sports final, a huge concert tour.
Yeah, the pressure is on.
Exactly. And you've got maybe 8 cameras, all shooting in uncompressed 4K. The challenge is, how do you get all 8 of those huge video streams instantly over miles of cable to the broadcast truck?
And they all have to arrive at the exact same time.
The exact same millisecond.
That high-stakes problem is exactly why we're doing this deep dive today. We're looking at the Thor Broadcast F-12G-8SDI kit.
Okay.
And our mission, really, is to unpack the tech that lets this system handle that kind of mission-critical job.
So let's just start with the core function, because it sounds like a massive shift. We're talking 8 simultaneous SDI signals.
Yep, up to full 12G SDI.
Over a single fiber optic cable. Just one. That's a huge simplification.
That is the key insight. You're taking 8 massive sources and putting them onto a fiber that's as thin as a hair.
How does it even do that?
It uses something called Coarse Wavelength Division Multiplexing, or CWDM. Think of it like using 8 different colors of light. Each video stream gets its own unique wavelength, and they all travel down the same glass core together.
So instead of pulling 8 separate heavy cables?
Exactly. You've just cut your cabling needs by, 87.5%, less weight, less setup time, and maybe most importantly, 8 fewer points of connection failure.
That immediately makes sense on site, and I see the default distance is 10 kilometers, which is plenty. But let's talk about the producer's #1 fear. Latency.
Yeah.
This thing promises 0 delay.
Well, yeah, it guarantees under 1 millisecond of transport latency.
Is that for real, though, across the full distance?
That performance is solid, and that sub-1 millisecond timing is, it's non-negotiable for live multicam shows. You're cutting between 8 cameras, you just can't afford a single frame of difference.
And it handles 2160p at 60 hertz, so it's ready for today's 4K workflows.
And for 8K in the future, yeah, it's built for it.
Okay, so we've got quantity solved with multiplexing and speed solved with latency. Let's dig into signal quality. The sources mention broadcast-level PRO DVB quality. What does clock recovery do?
This is where it gets really clever. The biggest enemy of high-speed digital signals is timing instability, jitter.
Right.
Both the transmitter and the receiver have a clock restorer. It acts like a digital regenerator. It takes a slightly messy signal, cleans up all that high-frequency jitter, and rebuilds it with a pure, stable clock.
So PRO DVB isn't just a marketing sticker.
Not at all.
Yeah.
It means the highest stability standards that major networks require for broadcast. It guarantees an error-free signal.
And then there's the second feature, automatic equalization, which solves a problem before the signal even becomes light.
Yes. This is operational genius. Video often has to travel down long copper SDI cables just to get to the transmitter.
And that signal degrades over copper.
Severely. So the input on this thing automatically compensates for that loss. It can equalize a run of 75 meters at full 12G speed, or even 600 meters for standard def. It cleans the signal while it's still electrical.
Okay, this is definitely professional gear. It's built for extreme temperatures, from -20 to +75 Celsius.
For sure. Perfect for a hot broadcast truck or a freezing press box.
But the price point is just under $10,000. How does a dedicated solution like this compare to, the big IP workflows like ST2110 that everyone's talking about?
Well, that cost reflects the guaranteed deterministic nature of it. IP is super flexible, no doubt, but this is simple. It's for a dedicated link. You bypass all the network configuration, the potential latency of IP switches. It's just rock-solid bandwidth that mission-critical events still really, really prefer.
So to wrap this up, this kit is really a perfect example of blending those massive high-resolution video demands with the kind of rock-solid reliability and low latency you need for live events. It just simplifies these incredibly complex workflows.
Which leaves you with a really interesting final thought. If technology like this guarantees lossless real-time transport of such massive data, what's the future of truly instantaneous global 8K live streaming going to look like? And what infrastructure bottleneck, if any, will finally prove the most challenging to overcome? Something for you to chew on.